Welcome back to Nature of Code in Rust in GGEZ. In this video, we're going to be going over exercise 1.4, write the limit function for the vector class. Now in this limit function, they give us some hints of where to go, how to do this. However, the real hint is here. What is the magnitude of velocity? If it's less than 10, no worries, leave it as it is. If it's more than 10, however, we want to reduce it to 10. So I'm here in the template. I want to update this here, and then I am going to create I'm going to copy the template over into the exercise 1.4 folder if you want to take a look at this code yourself to sort of keep it in time. So the way this is going to work, we're going to have a public function limit. Now I am doing this in the float side because we do need access to magnitude and normalize here. Okay, so we have limit, mute self, and we also need a max, which is going to be an F32. Actually, it's not F32, it's a T, where T is some kind of float. Most likely an F32 in our case. We're not going to return anything. So the first thing is if self.magnitude, so if our magnitude is greater than max, then we're going to want to normalize. So self.normalize. And then once we've normalized, we then want to scale it up. So self.multiply scalar by max. And that we can see here is exactly what we need to do. So the idea is that if our magnitude, if our length is greater than what we're going for here, so our speed is greater than, let's say 10, then we normalize it down so the magnitude becomes a length of 1, and then we multiply that by whatever we want this to really be. And no method named multiply scalar found for a mutable reference vector 2 in the same scope. We need mul assign in here. So let's go ahead and add mul assign. All right, and that gives us limit. Now, if I wanted to test this, make sure that this actually works, we can create some tests down here. So we're going to do a config. Well, how about you do what I want you to do? Config, no, not that either. I want config test. So when we're running in test mode, we want to mod tests. So this is basically a module, but it's in this file. I'm not reaching out to a different file for this. We're going to use super, so I can have access to everything above this. And then I want this next file to be a test. So I basically tell it, hey, you're a test. And then we're going to have a function. And this is the actual test function. So we should be able to limit vectors. We don't have to return anything. We can return results now. That's a relatively new thing that we can do in Rust, but I don't need to do anything like that here. So we're first going to set ourselves up. We need to create a new vector. So we're going to make this mutable. Let's just pretend this is a velocity. So velocity, new velocity is equal to a vector 2 new, and let's make this maybe like a 1.0 2.0. Okay, so let's see, what would this be? It would be 1 squared plus 2 squared. So 1 squared is 1 plus 2 squared is 4. That would be, see, 1 squared, 1 plus 4 is 5, and then let's make this 2 and 3, might be easier to calculate. So 2 squared is 4 plus 9 is let's see, 4 plus 9, that's 12. No, 13. Oh, that's not easy either. Is it 3 and 4? One of these is a good, easy combination. It's given us something like 5. Basically, so this is 9 plus 16. Oh, 25. So the square root of 25 is 5. So we know that the length should be 5. The magnitude of this should be 5. So that's perfect here. So if we want to scale this down or up, we should be able to like predict what this is going to be fairly easily. So if we have a velocity, let's say we create a an acceleration for this. So that acceleration is going to be a new vector, a vector 2, new. Let's say that I want to add, 1.0 and 1.0 to you. So we're going to say velocity plus equals acceleration. And then I want to limit the velocity to a length of like a max of 5, which is what we have right now. So we're going to say velocity dot limit 5. Then we can do our asserts. So we're going to assert equal that. I guess we can do like a couple different things. So first of all, we should have the x and the y should be the same as this. Now we have clone, copy, and debug. So we can have maybe like original velocity or like let result equals velocity. We clone this off and then we use it again here. So now we should be able to say our result is equal to velocity. Now, if I do this, this is going to yell at me because result and velocity, our vector 2 doesn't implement partial equal. Well, we can just infer this here by adding in partial equal. Now we don't have any other warnings here, and we can just run this test in line. We get a fail, so what happened? Left does not equal right. Oh, so it's really close we see here. Our vector is x is, so initially we have a 3 and 4, and then the right is this. Now, I'm curious, what would happen if instead I said dot magnitude and velocity dot magnitude? What would you say? Strict comparison of, oh, right. Okay. It doesn't want us to compare F32s with each other. So what I can do is just up here before the function, or maybe like at the mods, we can allow this type of comparison. So we can allow floats compare. And now for all of these modules, I'm allowed to compare floats with each other. Not usually the best idea, but I'm really curious to see what this is going to look like. So let's go ahead and run this again. And it passed. So even though it goes down to like, it's not exactly the same numbers after we do the limits, the magnitude is the same. So the magnitude result and the magnitude of velocity are the same, which should be 5.0. In fact, if I replace result with 5.0 and I rerun this, it's exactly the same here. So I'm actually just going to delete that, and there we have it. We now have that there, and we've implemented the limit, and we've implemented a test to ensure that the limit function is properly created. And that is exercise 1.4. It looks like we're going to be using that in the very next example for velocity with a constant acceleration. I'll see you in that video. Thanks. Bye.